Welcome to Ask and Learn.
To figure out the radius of convergence, we do limit as n goes to infinity of absolute value of an over absolute value of an plus 1, so absolute value of this whole thing, where the an's are just 1 over n to the fourth times 4 to the n. So this is limit as n goes to infinity of n plus 1 to the fourth times 4 to the n plus 1 divided by n to the fourth times 4 to the n. So this is limit as n goes to infinity of n plus 1 over n to the fourth, and then 4 to the n plus 1 divided by 4 to the n. Oops, sorry for that. 4 to the n plus 1 divided by 4 to the n. That's going to cancel out to just be 4. And then n plus 1 over n. As n goes to infinity, n plus 1 over n goes to 1. So this is 1 to the fourth, which is just 1. So 1 times 4, so we just get 4 here. So 4 is the radius of convergence here. For the interval of convergence, we need to check whether or not 4 works when we plug it in here and whether or not minus 4 works when we plug it in here. So when x is equal to minus 4, then we have minus 4 to the n over n to the fourth times 4 to the n. Sorry for the bad handwriting. Okay. So minus 4 to the n divided by 4 to the n, that's going to turn into minus 1 to the n. Because minus 4 to the n is minus 1 to the n times 4 to the n, and then 4 to the n will cancel out with the 4 to the n that we have down there. Okay, and then this will converge by the alternating sign test. And if we look to see what happens when x is equal to 4, then we would end up with 4 to the n divided by 4 to the n, so those would cancel, and we would just have 1 over n to the fourth. Since 4 is a number that is larger than 1, this would be something convergent. So this would also converge. Okay, so that works. So minus 4 works when we plug it in, 4 works when we plug it in. So we include both minus 4 and 4 in our interval of convergence. So we use these closed brackets to show that we are including them, and that's going to be our answer.